Greetings, I'm Jeremiah. Welcome to Mariculture Minute, a podcast about seaweed, salmon, and shellfish in Alaska. Except today, we're going beyond the 49th state. We're going to space. Rocket ships, planets, lasers, robots. Today's ocean farms are in the stars. We're talking space aquaculture, raising sea bass in lunar waters, growing spirulina on Mars, and maybe even farming oysters in the depths of Saturn's moon, Enceladus. Oh, and also, did you know seaweed could be used to shield space explorers from cosmic rays? We'll be scouring current research and scientific writing and attempt to go where no one's gone before, behind a paywall to read an article. Kelp Trek. Now, before we beam out, let's grab some vocabulary that might take us to the moon and beyond. First up, aquaculture. We call the farming of any food in the water aquaculture. This can mean fish farms, shrimp farms, oyster farms, seaweed. These farms can be freshwater species. It can be saltwater species. Aquaculture is growing food that lives in water. One form of aquaculture is vocab word number 2, mariculture. Mariculture, it's in the title of this podcast. Mariculture is growing food in ocean water. Marine aquaculture, ocean farms. These farms grow saltwater species. For instance, seaweed and oysters. Vocab word number 3. Get ready. Maybe have a seat. This is a long one. Integrated multitrophic aquaculture, or IMTA. In a word, IMTA is ridiculous, as in ridiculously awesome. Integrated multitrophic aquaculture. You take different aquaculture species, 2 or more, let's say salmon, kelp, and mussels, and you grow them together, and they benefit each other. The mussels filter out the fish poop and clean the water for the fish. The seaweed also uses some of the nutrients of the fish poop. The fish like swimming around the seaweed. They're happier, making happier fish poops. It's a cycle. Everybody's healthy. IMTA farms have many benefits, one of which is a more environmental footprint. It's sometimes called a closed-loop system. Even talking about it, I can see like a big tank on a spaceship with one of these IMTA farms, making food for astronauts and maybe even cleaning the air and water. But I'm getting ahead of myself. Vocab word number 4, in situ. In situ is a Latin phrase I have seen a few times when reading space aquaculture papers. It means basically on site or in its natural place. In space exploration, we have to make use of as many resources that are on moons, planets, and in space. We have to be able to identify in situ resources. Water may be an in situ resource on one of our space trips. We can find it on the moon, Mars, a bunch of moons around Saturn and Jupiter. There's a dwarf planet, I think it's pronounced Ceres, that might have water. Even Uranus and Neptune might have some nice H2O. And a handful of planets outside our solar system, like Proxima Centauri b and TRAPPIST-1e. So space aquaculture might one day be food grown in space water. Astroculture, cosmoculture, lunar culture. And vocab word 5. I might be pushing it, but here we go. Bioreactor. You know what? We'll just define this one when we get to it, but it's basically like a way to grow microalgae. So first, let's stop at the moon. Lunar Hatch is a project led by French scientist Cyril Perchbila. I apologize, I'm probably pronouncing that name wrong. Cyril Perchbila, to ultimately farm sea bass on the moon. According to a 2025 article in The Guardian, Perchbila sees astronauts on a moon base eating fish a couple times a week. The article goes on to quote Pershbila describing the moon's fish farms as an IMTA setup, a closed-loop system set up in a series of tanks. There'd be lunar ice for water. That's ice from the moon. That's like ice found on the moon. There'd be a tank for that. There'd be bivalves, zooplankton, shrimp, and worms in addition to the fish, to the sea bass. It'd be like an aquarium and grocery store in one. In a BBC article about lunar hatch, the reporter writes that fish makes a good space food because omega-3s and B vitamins can help astronauts help their muscles deal with the moon's gravity, with the lower gravity, or lack of gravity in space. Pershbila has written a lot about space aquaculture. I found a 2021 article he wrote entitled Space Aquaculture, Prospects of Raising Aquatic Vertebrates in a Bioregenerative Life Support System on a Lunar Base. Whew. That's a long title, but I think we can handle it. In the article, Pershbila writes about an aquatic farm on the moon, or Mars, purifying water and providing food. It also may have a psychological benefit for the astronauts. I know for me, just putting my hands in water kind of peps me up. I think what Pershbila is saying is that having all this water stuff, these things living in the water, it can lift up the moods of astronauts. Pershbila also writes that aquatic animals are much more efficient to raise in a space environment compared to land animals like chickens and cows. Fish require less energy, less feed, and less oxygen. In a space environment, a spaceship or a space station or a base on the moon, every bit of energy, food, and oxygen counts. He also makes a point. Developing space aquaculture could lead to better aquaculture technology on Earth. We could learn better ways to deal with fish waste, to create more efficient, environmentally friendly fish farms. Pershbila also mentions that aquatic cyanobacteria, otherwise known as spirulina, could be grown in bioreactors. There's that word. I owe you a definition. So, according to Wikipedia, a bioreactor is any manufactured device or system that supports a biologically active environment. I've seen bioreactors that grow microalgae, but they can also grow other stuff like cyanobacteria. Bioreactors, they're industrial-looking things with tubes, wires, tanks, and sometimes puffed-up plastic bags full of green goop. They look pretty sci-fi. Sometimes they even have red lights. Bioreactors can be microalgae farms. Pershbila writes, spirulina, which is a type of cyanobacteria, lives off sunlight and CO2, two things Mars has in situ. Spirulina could be a food source, a nutritious one too. It's got all sorts of good stuff in it. And growing inside a habitat, spirulina could feed off environmental CO2 and even provide some oxygen in exchange. It'd be interesting to see if it takes going to space to make more environmentally integrated ways to live. So these little things could work as a life support system and a buffet. In 2019, according to a Space.com article, the German Aerospace Center, DLR, sent an algae bioreactor to the International Space Station, or the ISS. The bioreactor was called the photobioreactor, which was meant to exchange the astronauts' CO2 for oxygen and also produce food, just like we're talking about before. Another 2019 article at sci-fi.com says the photobioreactor could produce 30% of the astronauts' food. The word to emphasize there is could. Because I found a lot of articles excited about the photobioreactor, but this was 2019, and I couldn't find a whole lot about how the experiment went. What happened on the ISS? Lots of articles about the photobioreactor going into space, not so many on it returning from space. Until I stumbled across a paper from the 2020 International Conference on Environmental Systems, which reported the photobioreactor met a cruel fate. From the article, an unexpected and not yet fully understood lack of power supply ended the experiment earlier than planned, after 2 weeks of operations. End quote. It also says, quote, O2 production and CO2 consumption cannot be evaluated since both substances were continuously being absorbed due to a leakage in the O2 absorber compartment. End quote. The report does cite some algae growth, which was higher than Earth algae, but ultimately the report says, quote, due to the shorter duration of the experiment, it was not possible to fulfill the experiment goals. End quote. A bummer. But science marches on, and I hope the photobioreactor returns to space one day. But it just goes to show you, you can find lots of articles excited about science experiments that are new and innovative, but sometimes you have to look a little extra hard for what actually happened in those experiments. A little science journalism tip. But we tend to think of spaceships and human habitats on other planets, space bases, cities on the moon, as things made of metal, maybe futuristic plastic, some type of weird canvas, there's glass, screens. But they might turn out to be structures with a lot of integrated living and wet stuff. I found another Space.com article about a Harvard research project to develop bioplastic that's a plastic made from algae. The research team claims that the bioplastic can be used on Mars to create stuff for Martian habitats. Here's a quote from the article. Unlike conventional industrial materials, which are expensive to transport and difficult to recycle off Earth, bioplastics can potentially be produced and reused on-site using biological processes. Which, again, makes me wonder, why can't we do some of this amazing stuff on Earth? Can we just grow our own bioplastics instead of going to the store? I mean, I'm all for going into space. It's awesome. But some of this amazing problem solving seems like could make living on Earth a little easier. Perhaps all the more reason to pursue space travel. All the swag we'll discover on the way. I found another European project looking at farming sea bass, which by now I think we might want to call space bass. Another project working to build off the work of Lunar Hatch is a French and Catalan research project called Space Gen Fish. Space Gen Fish is looking to analyze how a fish's epigenetic mechanisms work outside Earth. What are epigenetic mechanisms? I have no idea. No clue. But I think it involves how a fish's genes are expressed in space's microgravity and with space radiation and other space stuff going on. That's according to an article I found at missspecies.com. I'll put a link for that in the show notes. The article also explains that the technology developed to monitor the fish for the experiment that Space Gen Fish is doing, that technology could also be used to help with remote fish farms right here on Earth. I also found an article at globalseafood.com. This article is about a Japanese research project led by Toshimasa Yamamoto at the Okayama University of Science. These researchers want to farm fish and shrimp in space. The project is cool because it uses this artificial farming water. It has a stable pH of 7 and a set of vital nutrients. They call it the third water. They made their own water. This is sci-fi. The third water can grow both salt and freshwater organisms together. Weird, huh? The system Yamamoto's research team is working on is called, get ready, Closed Recirculating Aquaculture System, or CRAS. CRAS is a closed-loop system that can be fully automated for 3 months. The goal is to conduct an experiment with CRAS on the ISS around the year 2030. So again, this is science that is very much alive right now. We've talked about fish, shrimp, algae being farmed in space. But what about everyone's favorite? Oysters. An article from just last week, April 8th, 2026, in Harrisburg Today reports students at Pennsylvania's Harrisburg University have teamed up with the private company Monolith Space. This research team has designed a prototype to grow oysters in space. The article writes the project's goal is to create food and a water filtration system for astronauts on trips to the moon and Mars. The system could provide some delicious food and turn gray water to water suitable for growing plants. In another article at spacebotany.uk, the article has this awesome title, Shall We Go to Space? Emma Doty writes, the oysters being farmed will be the eastern oyster, but perhaps one day it will be known, this is me talking, one day it will be known as the star oyster. Doty goes on to describe this oyster farm prototype as an aquarium with a closed loop system. So I'm kind of visualizing like a tank with tubes that could sit on a shelf in the space station. The goal of the research team is to eventually test the prototype on the International Space Station or a commercial space station. Any space station will do. Who wants oysters? That's all. That bit is from a Yahoo article at yahoo.com. So, we got space bass, star oysters, microalgae, cyanobacteria, shrimp. What about my favorite? Good old-fashioned seaweed. Where's the space kelp? To articulate my argument, I go to Reddit from a post by Starcrafter. This is from 7 years ago. Quote, hear me out here. Kelp. It's one of the most nutritionally dense crops on the planet, grows at multiple feet per day if adequately maintained, and converts dissolved CO2 into O2 far more efficiently than land-based crops. Its byproducts are useful for a variety of chemical processes, especially if you grow other seaweeds alongside it. And it also filters water that can be used for drinking later. As a bonus, it grows perfectly fine along with algae or other biomass that can be converted into food, fuel/useful chemicals. Sure, you'll need long, translucent tanks of water, but water really shouldn't be all that difficult to gather in situ. And the volume required for a cylinder growth chamber is much less than for a full pool-style tank. You can also mount the tanks above your habitats for radiation shielding if you want. It can be dried, like jerky, as is, and stored for long periods of time with minimal volume requirements. You also need to purify existing percolates out of far less regolith volume for use with kelp than you will for things like potatoes, with respect to how much usable food mass you get out of it. End quote. A solid argument that begs to be fact-checked, but still, there has to be more about space kelp than this Reddit thread, right? Right? I'm seeing lots of articles about microalgae in space. What about macroalgae, seaweed? Well, there's this academic research book published just this year titled Advances in Temperate Phyconomy, Algal Harvest and Cultivation in Globally Distributed Temperate Waters, Part 1. And in this page-turner is a chapter titled Algae at the Final Frontier, a review of the potential applications of macroalgae in space. This is exactly what I'm looking for. Let's go grab some quotes. It's behind a paywall. But I can see the abstract, which says this paper looks at the role macroalgae can play in bioregenerative life support systems on the moon and Mars. Here's a quote. Built using biological and ecological approaches, BLSS will facilitate effective resource management, improve mission security, reduce costs, and limit the environmental impact of these settlements both on-site and on our own planet. Considerable thought has been spent on the roles various photosynthetic microorganisms and plants can play in BLSS. Here, we explore how macroalgae could contribute to BLSS and how biology will fuel the next great leap. End quote. Fascinating. In addition to this paywall article, I found a 2024 research article by Marco Lemos titled Beyond Earth, harnessing marine resources for sustainable space colonization. One thing that caught my eye right away was Lemos proposing algae, particularly microalgae, could provide biofuels for astronauts. But in regards to macroalgae, and Lemos writes, seaweed could provide space explorers with food rich in protein, minerals, and vitamins. Lemos also writes about how algae in general could help astronauts manage exposure to space radiation. And he singles out the seaweed nori. Here's a quote. The integration of nori extracts into spacecraft shielding materials, or dietary supplements, is being explored by researchers as a means to augment the radiation protection provided to astronauts during space missions. Wow! Is there anything seaweed can't do that sound protect astronauts from space radiation? That sounds amazing. But honestly, I'm surprised just about how much research is going into space aquaculture. I had no idea. We have research teams around the planet trying to farm fish in space. We got college kids putting together a space oyster farm. Harvard is working on self-sustainable bioplastics to grow on Mars. And all sorts of people are looking at growing microalgae in space stations. I wonder how it all might come together. A beautiful ocean farm in the stars. And looking at all this research just makes me realize if we go into space, we won't be going alone. We'll have to bring our environment with us. Our air and our water. Which makes me realize even more how connected we are to the oceans. We can't get away from them. It's kind of a cheesy way to end the podcast. But to space! Special thanks to W for the music. I'll include links to all this stuff in the show notes at kelpshow.com. I even found this link about this, this building, this idea for a building that's like half microalgae bioreactor, half building. Like this article was describing using like these oil pipelines in Europe, repurposing them for microalgae bioreactors, and just have microalgae flowing everywhere as an energy source. And that link will be in the show notes, as well as all like the space stuff and scientific articles and BBC and Yahoo and the spacebotany.uk article. All that stuff will be at kelpshow.com. You can listen to Mariculture Minute at Apple Podcasts, Spotify, YouTube, and at kelpshow.com. I'm on Instagram at kelpshow. Once again, I'm Jeremiah Murphy in Sitka, Alaska, and you are listening to Mariculture Minute. Thank you so much.